So many real-world scenarios can be modeled using systems of equations. So up until this point, we have learned how to do systems of equations with graphing, with substitution, and with elimination. So now we're going to be modeling with it, which just means use word problems and try to figure out, we have to set up some equations and then solve them whichever way is easiest. So Jonathan has 9 bills in his wallet that are all either $5 bills or $10 bills. John has more money than I do. So fill out the table to see the dependence of the two variables and how they then determine how much money Jonathan has. So we know that he has 9 bills total. So if he has 9 bills total and 0 are 5s, then there are 9 10s. If 1 is a 5, then 8 are 10s. If 2 are 5s, then 7 are 10s. If 3 are 5s, then 4 are 10s. Oh, sorry, not 4. I'm adding up to make 9. So 6. Goodness gracious. So now we look at the amount of money. So I'm going to go through and look at if there are 0 5s, then that's $0. If there are 9 10s, then that's $90. So 0 plus 90 is $90 total. If there is 1 5, then that's $5. If there are 8 10s, then that's $10. Sorry, $80. So 5 plus 80 is $85. If there are 2 5s, that's $10. If there are 7 10s, that's $70. 10 plus 70 is 80. And 3 5s is 15. 6 10s is 60. 15 plus 60 is $75. So if F represents the number of $5 bills and T represents the number of $10 bills, then what does the following expression calculate? Well, what this expression calculates, the 5F is how much money in 5s. So how much money in 5s. And the 10T is how much money in 10s. So if Jonathan has a total of $55, set up a system of equations involving F and T that could be used to determine how many of each bill he has. Solve the system. Remember that he has 9 total bills. So if we're talking about amount of money, we're going to use that small little semi-equation that was listed up above of 5F plus 10T, because we're talking about how much money each of those is worth, but we know that we have $55 total. And the next equation just talks about the actual bills we have, the types of bills. So we have 5s, we have 10s, and we have 9 bills. So now we can solve this system of equation. You can solve by elimination, you can solve by substitution. When it's set up this way, I usually just resort back to elimination every time. If you would like to pause and try it by substitution, that's fine. You should end up with the same number of 5s and same number of 10s that I do. So I'm going to solve to get rid of the 5s. So I'm going to need to multiply by 5. But in order to eliminate, I have to multiply by -5. Remember, everything in that row gets multiplied by -5. So -5F minus 5T equals -45. And our top equation, I'm just going to move it over, so 5F plus 10T equals 55. This is now a giant addition problem, right? So the 5s eliminate. We're left with 5T equals 10, divide by 5, and T equals 2. So there are 2 $10 bills. So 2 $10 bills. And if we look at this equation, F plus T equals 9, that means that there are 7 $5 bills. So let's say that we were told that Jonathan had 7 bills that were all 5s and 20s, And we were also told that he had a total of $120. So we're going to use the same type of information that we used up above to determine if we were told that it was true information. So my first one, all 5s and 10s. And we know there's 7 bills. So 5s and 20s. So 5s plus 20s equal 7 bills. The next part of it is we know we have a total of $120. We know that $5 bills are worth $5 and $20 bills are worth $20. I'm going to do the same thing I did up above. I'm going to eliminate, so I'm going to multiply everything by -5. So negative 5f minus 5t equals negative 35. I'm going to transfer over the bottom equation. So 5f plus 20t equals 120. If we look at this, the f's eliminate. We're left with 15t equals $85. Divide each side by 15. And I end up with a decimal. My decimal is 5.6 repeated, or 5.7. I should come up with whole numbers. So since I should have come up with whole numbers, it is not true. So not true information. There are many different problems that could be modeled with linear systems. Let's try another one where we use information given to determine unit prices. So Samantha went to a concession stand and bought 3 pretzels and 4 sodas and paid a total of $11.25 for them. Raza went to the same stand and bought 5 pretzels and 2 sodas and paid a total of $8.25. So could pretzels have cost $1.25 each and sodas $1.50 each? So if Samantha, so let's look at Samantha first. If she got 3 pretzels and the pretzels cost $1.75 and 4 sodas and the sodas are $1.50 each, hers should equal $8.25. And then for Raza, she should have, so she got 5 pretzels, so 5 times $1.75, and 2 sodas, so 2 times $1.50, and it should equal $8.25. All right, so the first thing we're going to do is 3 times $1.25. So $1.75, and that's $5.25. Then 4 times $1.50 is $6. And, sorry, I wrote $8.25. That should have been $11.25. Sorry, guys. So add those together, and you get $11.25, so it works. For Raza's, 5 times $1.75 is $8.75. Wow, 5 times $1.75, so 5 pretzels. So you should see already that there's no way that that was the cost because this does not work. So no is the answer. So by letting x equal the unit cost of a pretzel and letting y equal the unit cost of a soda, we're going to write a system of equations. So for Samantha's, it's going to be 3 times x, because that's the cost of a pretzel, plus 4 times y, since that's the cost of a soda, and hers is $1.25. For Raza's, it's 5x plus 2y equals $8.25. So solve the systems using the elimination method. So since I'm just going to rewrite them real quick. 3x plus 4y equals $11.25, and 5x plus 2y equals $8.25. Some of you are still a little confused on how you know what to multiply by in order to eliminate. The first thing you want to look at is the coefficients of the x's. Can I multiply one of those by one number in order to get to the other one? No. But I'm going to look at the y's, and I can. I can multiply the bottom equation by 2, but it has to be negative in order to eliminate. So that one becomes negative 10x, negative 4y, and $8.25 times negative 2 is negative 1650. I'm going to rewrite the first equation. So 3x plus 4y equals 1125. All right, so the y's eliminate. We have negative 7x equals negative 525. Divide both sides by negative 7. And your pretzels cost 75 cents. So our x is 0.75. To solve for y, you're just going to plug it into either one of the equations. I'm going to use a top equation. So 3 times 0.75 plus 4y equals 1125. 3 times 75 cents is 225, so we're going to subtract 225. So 4y equals $9. Divide by 4. And y is a soda, so equals $2.25. So if Leah went to the same concession stand and bought 2 sodas, how many pretzels would she need to buy so that she spent the same amount on both? So if she went to the concession stand and bought 2 sodas, and we know that the sodas are 75 cents, so 2 times 75, we want to know how many pretzels would she need to buy. So how many pretzels would she need to buy when we know that they cost $2.25, so that she spent the same amount of money. I did that wrong. Sorry. Oh my goodness. Sodas are $2.25. And we know that pretzels are 75 cents, and we need to know how many that she would buy so she spent the same amount of money. That makes a lot more sense. So $2.25 times 2 is $4.50. We want to know how many pretzels, so divide by 0.75. And that is 6 pretzels. All right, we can model information given in a geometric form as well. We should feel relatively comfortable working with rectangles and their perimeters. So the next question concerns the relationship between the length and width of a rectangle. So a rectangle has a perimeter of 204 feet. So I'm going to draw a rectangle. The length is 6 feet longer than twice its width. So twice the width plus 6 is the length. And we have our width. So write the system of equations that models the information given in the problem and solve it. So, because this is the same thing as our length, right? So we have a system where 2 times width plus 2 times length is 204. But we also know that the length is 2 times the width plus 6. So we're going to have to use substitution for this one. We're going to substitute 2w plus 6 in for this L. So 2w plus 2 times 2w plus 6 equals 204. 2w plus 4w plus 12 equals 204. 6w plus 12 equals 204. We subtract 12 from each side. 6w equals 192. Divide by 6. And the width is 32. So if the width is 32 feet, to find the length, we're going to plug 32 in here. So 32 times 2 plus 6 is 70 feet.